All right, hands-on science cycle 3, week 16, using Van Cleve. Also using Nicole Liam Yang's notes, but also changing the experiment. Instead of using a straw with a balloon, we're actually going to be attaching the balloon directly to a bottle. So just follow along as I go over it. But first, let's talk about, so today we're going to make a chemical reaction. Let's learn about how molecules mix and rearrange themselves. So what kinds of questions might we have just knowing what I just said? Maybe like, how do molecules rearrange? What is a chemical reaction? What have you already learned? Have you already learned anything that might help us here? What's a mixture? When do we mix things that maybe you have some experience with? Like baking or cooking, we mix ingredients together, right? What are physical properties versus chemical properties? We talked about this last week. So the physical properties are properties that we use our senses to experience, and chemical properties are those other things. What do we still need to find out? Maybe what is the difference between a mixture, a solution, and a compound? What do we think will happen when the baking soda mixes with vinegar in the bottle? How will that affect a balloon? What do you think? Do you have any ideas? Will it just dissolve into the water? What's going to happen? Okay, so to do this experiment, which is a tweak on the Van Cleve experiment, which is what Nicole Liam Yang references, we still need vinegar. Here's a huge jug of vinegar. We need baking soda, a teaspoon measure, funnel, balloons, and this is one per kid. We need a measuring cup. We need water. And we need a bottle. So I'm using these again from cycle 2. Remember, we use these to fill with water and then bang on and hear their sound. I still have them, so we're going to be using these. If you don't have glass ones, you can use a plastic soda bottle just fine. So some kind of soda bottle. And the first thing we're going to do is we're working in pairs, and we're going to put half a cup of water and half a cup of vinegar into each bottle, all right? All right, and half a cup of vinegar. Okay, the next thing we need to do is attach a balloon to the bottom of the funnel. All right, and we need to hold that tightly because we actually need to put something in the balloon, okay? So this is kind of a two-person job. One person holds the balloon tightly so that it's not going to come off the funnel, while the other person puts the teaspoon of baking soda into the funnel. All right, so once that is in the balloon, you can take the balloon back off. And we're gonna keep our balloon down because we don't want our baking soda to go anywhere, okay? So keeping our balloon hanging down, keeping it limp, we are going to hang it down the side of the bottle and attach the balloon to the opening of the bottle, okay? And some of the kids are probably gonna need help with this. All right, so I've got it on there pretty securely, right around the lip. You want to make sure it's on pretty securely. Now, holding tightly. Now, what's about to happen will not hurt you, okay? So nobody needs to be afraid to do this next part. The next part is someone needs to hold on tightly to the balloon that's around the edge. All right, so one of the people in the partnership. We're gonna use our dish pans. Guys, these dish pans are from the dollar store. They're the best. Get a lot. All right, so I'm gonna hold this nice and firmly. And then get ready. I love to let the classes do this all together, like wait till everybody's ready and then do it at the same time because it's really, really fun. All right, so I'm gonna keep a firm hold on it. Can you see the bubbles? Whoa! And actually, when I pick up my balloon, there's liquid that actually went up into it, and then it's able to stay up a little better. Actually, it's doing it again. It's bubbled again. Woo! Yeah, hold on tight or else your balloon might fly off and create a ginormous mess. And ultimately, my balloon stays up. When the reaction stops and I get all the liquid out of the balloon, my balloon is staying up. And for the record, I made no mess. It's not wet at all in here, but this is still, good to have just in case. So, what did we just observe? What did we just observe? Let me bring you closer. Okay. The atoms that make up the elements in the periodic table mix, match, and rearrange themselves to form all the things we see in the world around us. They might combine to form molecules like our H2O water molecules, or different molecules might combine to form mixtures like pebbles in the sand on the beach. Some mixtures have dissolved substances like salt water. These are called solutions. All mixtures, including solutions, have something in common. Their change in form was only physical, and the original molecules can still be separated again. Sometimes it's simple to separate the different molecules using a coffee filter or a sieve. Other times, scientists might need to separate liquids from solids with boiling and evaporation, or distillation. There is a type of change, however, that cannot be separated back into its original molecules. This is called a chemical change. The molecules actually break apart and rearrange their atoms with other molecules they encounter. They go through a chemical reaction, creating completely different and new molecule called a compound. Imagine a cake where you combine eggs, flour, oil, sugar, and water. When you bake it, no amount of separation can return it to its original ingredients. The same kind of chemical reaction is happening in our baking soda and vinegar experiment. When the molecules combine, they produce a chemical reaction that makes something new, carbon dioxide gas. As the gas floats up to the top of the bottle, you can see it pushing outward, forming a bubble in the balloon, blowing up the balloon. Isn't that cool, guys? And this would be a really easy one to duplicate at home. So I'm going to take this off now and let it go down.